Welcome back. My name is Magnus Bäck. I work with CI tooling and related tools at Access Communications. And this talk and discussion is about how you could use Eiffel to implement event-triggered pipelines and the struggles we've had in doing so. So I hope folks will have interesting ideas or general discouragement, let's see. So our pipeline, so a little bit of background. We work, or at least I work mainly with Access's firmware builds and test pipelines for our firmware for our products. And these pipelines used to look like this. So a pretty linear flow. You build one product, you test that product in a hardware lab. So it's fairly lengthy builds, or at least used to be, and quite a few products, could be upwards of 50 or 100. But it was pretty straightforward. All the products, there was a one-to-one mapping between what was built and the hardware it was tested on. So scale-wise, it could still be difficult to, obviously if you have 100 build jobs, 100 test jobs, you don't configure them manually. You would have to generate the jobs or something similar, but otherwise fairly low complexity. Problem is we're moving more towards pipelines that look like this, where you have fan-out situations with you build one configuration, you test it on multiple hardware, or you test compositions of different software. And this gets very unwieldy with how we have pipelines today, but it lends itself very well for using Eiffel. And that's one of the reasons why we're so interested in Eiffel. But it turns out implementing this using event triggering based on Eiffel pipelines is a little bit more difficult than we hoped it would be. So if we zoom into a small portion of this execution graph here, where we build two products, wait for both to complete, and then we test the composition, the upper part of this slide. It could look something like this in the lower part of the slide, where we have two independent builds. They produce artifact created, artifact published events. We would have some kind of aggregation service that awaits, listens to the bus and waits for the artifacts to arrive. When matching artifacts have arrived, we construct a composition from them, send that, and it will be picked up by some kind of test process. In theory, this works really well. You might want to write the aggregation service as a separate service. Could be developed by a different team, maybe the team that owns this particular combination of products, for example. Quite appealing instead of the large monolithic configuration that produces an execution graph like this. The problem we see with this is how we should track failures. The happy path is pretty straightforward. Again, you listen to events and you publish your own events and things work out fine. But what if there are either nothing is happening? Let's say the aggregation service is down for extended amount of time. What would you do then? That case could perhaps be handled with timeouts, but that's insufficient for other purposes. Perhaps bigger problem is what if the build for product one, for example, what if it fails? And you will obviously never get an aggregated composition, and you will never get a test result. Who is going to notice that? How will that trickle back to the person observing the whole pipeline execution? So that's what we haven't really been able to really figure out how to do. Our current best idea how we think we want to do this, is to actually have a central orchestrator, which sort of goes against the grain regarding using event triggering. But to properly handle errors, we feel that we need to have that central orchestrator, or at least someone that has the whole execution graph as that observability and would be able to figure out that if we get a failure in one place, how is that going to affect the end results? What are the end results anyway? And when would we have to signal a failure to whoever initiated the build? So our idea would be to have sort of observability domains, or whatever would be a better term, where we don't want to have a single orchestrator for like every single Eiffel activity in the company. That wouldn't make sense. We would want to have some kind of compartmentalization. So we would have, like, if this is a pipeline that builds and tests firmware products, and this would be some other, maybe another organization doing some other kinds of tests. These would run under different observability domains, and a failure here wouldn't result in, this pipeline failing, while a failure here would indeed result in a failure in this pipeline instance. That's our current idea. So I'm very curious what you might have to say about this. I know that in the very first presentation, Christopher Hallén cautioned against using these kinds of using event triggering within a pipeline and using it more for inter-pipeline triggering. On the other hand, implementing an execution graph like this in something other than an event triggered fashion is, or event triggering doesn't really matter, but implementing it in Jenkins or possibly other similar kinds of tools where you through configurations, YAML files or whatever, have to wire these nodes together, is, especially if you want to have it dynamic and have users be able to express in a dynamic fashion what products to build and which ones to test and what should be the test scope and so on. That also doesn't lend itself well to the more static configurations that are, I think, usually used in CI tools.
Well, Christopher here. So no, and so maybe that, yeah, elaborating on that, I think that, yeah, you don't replicate functionality if someone else is doing it better. But as you say here, you might see that, as you said there, the static pipeline or this tool that we have is not doing it better. We actually need the events here. So I think we have gone from Ericsson we focused a lot of triggering in the beginning, and then we went all in with one tool where we had everything was an event, or but we ended up with something that was a lot to maintain, and it didn't really give. There were many reasons, but we felt that it wasn't really, we were replicating a lot of outside functionality we could get in other ways. And so now we step back a bit. We have a lot of triggering, definitely, but I would say more the way you are showing it here, that within bounded contexts, there is a knowledge about what should be going on, but outside of that, you only care about, so the next step, maybe it's a new process step or organization using something, then you don't care about the inside. You want to say, is there a complete event chain for me, and are there things that I can trigger on? But if you, maybe we could look up what we ended up with there. But I think we had some problems with having everything triggered everywhere to the smallest detail.
Yeah, I think another thing that I forgot to mention that is a bit annoying if you're using existing tools is that you still want the complete Eiffel DAG. And if the triggering is Eiffel based, you will get the Eiffel DAG for free, because you will obviously, if you're triggered by an artifact creation, for example, you will obviously set the events that you emit will obviously have the correct causes. But if your pipeline execution graph is driven by some CI tool that where event triggering doesn't take place, you have to sort of piece together things, you sort of reverse engineer things to get the correct Eiffel DAG, which is, well, certainly possible, but has a cost. So therefore, what we are, I think, going towards is having a central orchestrator, but making it Eiffel-aware. So internally, it's sort of, the configuration is driven or is expressed in Eiffel terms. For example, you might say that we should make a build, and we expect it to produce the following package URL, or, well, artifact with that package URL. And we set up that, well, we have these test activities that expect the following package URL. So sort of internally in the orchestrator, we center it around Eiffel events, but it's still technically the orchestrator that decides what to actually trigger. But these are just very loose ideas. We haven't fleshed it out in any way.
To relate to some stuff here, I think what you're showing in this picture is pretty much in line with how we are discussing this. We, from a conceptual perspective, when we refer to events, we either refer to them as flow start events, and these would be the arrows that you have between the gray boxes here, or flow continuation events, which is when we need to trigger inside a flow or a pipeline, just to like make the next step happen and tie everything together. And that kind of terminology helps us, because then we can say, as long as it's a flow continuation event, then it should be possible to visualize like how far did we get in this pipeline. Whereas when something is a flow start event, that means, okay, now we're starting a completely new pipeline, so we will need to visualize that separately. And then define what we would call triggers, then, which could be both flow start triggers and flow continuation triggers, like what is the criteria for when I should start the next activity or start this new flow. So I think that is pretty much in line with what we see here. I can also mention in Volvo Cars, they have what I would define as an event triggered system. They have a message bus and a vocabulary, which is quite a lot simpler than Eiffel, so really generic. But they have a service then where all teams and departments can register a trigger, which is basically a filter criteria for messages, saying that when a message arrives that looks or matches this filter criteria, please go invoke this URL. And in many cases, that URL is a Jenkins build start URL. So that starts a Jenkins job somewhere. And then whether that runs a whole pipeline or just a single job, that's really up to them. And then they can also define manually, I think, like here is how some part of my pipeline looks. So when you visualize it, if you have seen this message over here to the left, at some point we should see some results for this activity over here on the right. And that is used then to visualize sort of progress in the pipeline. But yeah, that is a bit of manual work, I would say. But yeah, I definitely see a use case for being able to run internally in a pipeline based on events. I think it makes it really easy to tie different systems together, as long as you have, as you said, some orchestrator that is aware of what events are supposed to come and how they look.
Yeah, interesting. We've Volvo Cars nowadays has a fairly large site in Lund, where literally across the street from Access headquarters, and so obviously we know a lot of folks there. So we've been talking to them about having them present their event-based pipeline to us, and we're a bit curious why they chose to go that route instead of working building it up on Eiffel.
Yeah, it is a bit curious, especially as I think many of the people who built the CI solution for Volvo Cars are actually old Ericsson employees, so they definitely knew about Eiffel when they started.
Yeah, also heard that was started by people that came out of the Eiffel background.
Old Ericsson folks and some old Access folks, and a lot of folks from Sony as well.
But Emil, what would you say that what Magnus said, that everything, we say the same thing, everything here shall be Eiffel-aware. We want to tie together all event chains with, for example, the solution you're working with, but we don't trigger every step explicitly.
Exactly. I mean, it seems like the industry is going towards orchestrator-driven pipeline executions, and that is, I guess, what you, Eric, referred to as flow continuation events. It could be sent then from such a pipeline orchestrator, like Jenkins pipeline, like Argo, like Tecton, like more or less whatever nowadays. Seems like you have a predefined pipeline definition somewhere that states what steps are to be followed after each other in this pipeline. And then when the pipeline finishes, you probably have published some artifact somewhere, or tested something, or deployed it somewhere. Then that finishing event could trigger something else, or also, as you also said, Eric, these internal flow continuation events could then trigger an external thing to happen. And that's what we are looking at in Ericsson, I think, mostly today. I would like, if you go back, Magnus, to the slide where you show the integration, the aggregation service, you call it, yeah. So what we try now, at least parts of us in Ericsson, that we try out having a event-driven aggregations, if we should use these terms. We call them integrations, I guess. So those are always, or the one idea at least, is to use events to always trigger those integrations or aggregations. And that means also that to the left of that aggregation, we have, I mean, that part is there is responsibility for that build or that artifact, that product, or whatever we call it, which has some source code involved with it, and build scripts and test scripts and whatever. And then whenever that part is done and it's not integrated, but it's published somehow, that the team responsible for that product or that sub-product says that now we are confident in this and we can release it, we can publish it, then that could trigger the next integration level. And there could be multiple levels in such an integration hierarchy or aggregation hierarchy. So, and then of course you would follow your own commit within your own product pipeline there for your sub-product or whatever. But you would of course also be interested in what happens to my product now when I've published it. So of course they're interested in following downstream through some kind of follow my commit or whatever, see what actually happens to this afterwards. Not that they are interested in if something does not happen really, but they could be interested in seeing, yes, it happened. And for the same reasons, the team there responsible for the aggregation level in this picture, they would not be very interested in when an artifact failed to be created upstream, because I mean, okay, apparently that team responsible for that sub-product didn't do what they thought they were doing. They didn't manage to create an artifact that I can integrate, so why should I care right now? I mean, they will tell me when there is a new artifact that I can trigger on. So I think that's at least in parts of our pipelines, we have that idea to look into that kind of division of responsibilities. And then, of course, there will be some overall project looking into all these different product integrations and wanting to know why don't we get any new integrations there? There should come a new product from that area where that can be integrated, and then these things happen. And of course, they would want to see all these different sub-pipelines, so to say, in some view as well. And then, yeah, maybe I should stop there for now.
I have a Candace here. I have a questions like because like since like you said that we should build like a orchestration tool like for the Eiffel pipeline, because like from what I know, like in Ericsson, like we have Jenkins pipeline, you know, like each Jenkins job triggering another Jenkins job, another Jenkins job triggering another Jenkins job. But in each Jenkins job, like you are sending like different events, you know, like you're not really sending only one event. How do we like how do we like make these two pipeline combine together? Would it be a little bit? There's one pipeline inside another pipeline, or how?
So I think I would go back to what Emil said before. The way we would do it is we have some sort of definition for not just a single pipeline, but the whole, well, not just a single Jenkins pipeline, but the whole like Eiffel level pipeline, if you want to call it that. And there you could simply say that, okay, you have this first Jenkins pipeline that does maybe a build from source code. And then later on, you have a Jenkins pipeline that does simulator verification on that build. And you would tie those together, not through Jenkins, but through Eiffel. So the build Jenkins pipeline ends by sending, for instance, an artifact published. And that is the event that the simulator Jenkins pipeline is waiting for. So that will go to the Eiffel-aware orchestrator, which will in turn invoke the Jenkins simulator pipeline. And that kind of way you tie everything together. So there would be a definition of the higher level pipeline or flow outside of Jenkins. So Jenkins itself doesn't really know how things are connected. It's the outer orchestrator that knows how things are connected. That is the solution that we are looking into, at least.
Yeah, that plays well along with what we're thinking too. One of the problems we have currently is the setup of the jobs with the scale that we have. So, I mean, if we look at this, since there are so many products, so many jobs, and then you have one pipeline like this for every team. So enormous amount of jobs, which creates problems in itself. So we would very much want to go to a position where you could have maybe one generic build job that basically everyone uses. And I mean that job could have 100 builds going on in parallel. But you wouldn't need to have tens of thousands of Jenkins jobs, because that creates various problems. And if you have the orchestrator, it could invoke just about any job, and Jenkins would be sort of unaware of what the whole pipeline would look like. So I think that's a good approach.
I think like right now we are like using like the input event ID to do these connections like between like a different pipeline, and also like they have some confidence level. Then like use the CL event, you know, like if this one like pass some certain test level, you will put like something like CL1, confidence level 1, 2, 3, and 4. So it's still kind of like able to I don't know, like I think like currently we already have like a problem like that, like it's still kind of like working like in the legacy system, like we still, yeah. So I'm not very sure about like what exactly, you know, like can be done in these orchestrations. I understand the concept, but I think I still need some time to reflect it. How does it bring it into our current system? Yeah.
Yeah, it might be quite a lot of changes. From my perspective, I've seen it work. I would say Volvo Cars is using something quite similar to this, or at least some departments in Volvo Cars is using this this way of triggering jobs. And when we are looking at it as well, I mean, conceptually it works out. I'm sure there are a bunch of like edge cases and scaling issues that are to be looked at, as Magnus said. But from a conceptual level, this seems like a quite safe way forward.
All right, well, lots of great input here. Thank you. We'll see how we move forward. That could definitely be a topic of a monthly meeting or the next summit or something, and talk about what we ended up with.
I think it's great that you bring up these use cases, Magnus, and we have, I think, quite good discussions around them. It's good to be able to share how we use Eiffel events and not just what Eiffel events we should use and what they would look like. Real world scenarios is great. Great input, everyone.
Magnus mentioned missing events in his presentation, like there is maybe the aggregator was down or something that results in events not being sent that you expect to be sent, or maybe there is some tooling issue in the pipeline somewhere so that an event is missing. Have you in Ericsson got a lot of experience of this? Do you handle this in some way, or do you just let them slip away?
Or one part of the answer, at least, maybe not how we handle it, but we had a lot of discussions and maybe like the rumors about, yeah, we lose events, they are missing and that kind of thing. But and then we did an investigation, and the conclusion was that when an event actually was in the system, out on the message bus and ER and those kind of things, then it's super stable. We don't, yeah, I don't think we ever lose anything. But what the problem was more that we had, yeah, maybe we had written clients that didn't really check if the message ever was sent, or we had clients that didn't really list or parse events the way that they could handle it. Those kind of things. So it was the interaction with the backend that was the problem. So then at least we found that the system itself is stable and good, but we need to be very careful about how clients interact with it.
Okay, so you essentially found out that you don't need to kind of handle this problem. You focus on writing good clients, and then it will work.
Yeah, that was our biggest problem, that when data was missing or we couldn't find an event. It wasn't that the event was lost, it was never sent, for example.
Yeah, so there wasn't a problem with messages being lost in transit. It was rather that then the messages are not sent as they should, and maybe that's actually what you're asking for, Johan. If the artifact is never created, what do you do then? Really, I mean, if the event hasn't occurred even. Or was that what you actually asked for, Johan? Or was it?
I think I was more into what Christopher described, that if something went wrong, that events were lost somewhere.
Yeah, then so, it's a bug and needs to be fixed.
Yeah.
Yeah.
Good. Thank you.
Great, good discussions. Thank you.